Hey everybody, welcome to our SAT office hour. And this topic today is linear functions. But before we dive into that, let's get started on reviewing our weekly challenge problems. We have four of them this week. So here we have Akira has $360 in her bank account. She spends N% of it to buy a dress. After buying the dress, she spends N% of her remaining money to buy a wig. If she has $230.40 left after buying the dress, what's the value of N? So for right now, I'm going to ignore that it says N%. I'm going to say that she has $360. And then when she spends N% of her dress, like for instance, if she spent 30% of her dress, or if she spends 30% of it to buy a dress, then what we're concerned about is how much money she has remaining. Again, then she spends another N% and she has $230.40 remaining. So, like for instance, if she spent 30%, then she would have 70% remaining. All right. So, what I'm more concerned about is, I guess, what percentage she has remaining. And that's what I'm going to multiply by. So, it's like whatever, I'll figure out what she spent after the problem. So, it's like we did 360, we multiplied it by some amount or some like decimal. That's a better way to look at it. And then we multiply by that decimal again, which is not going to be n. That's why I'm choosing a different variable. And then in the end, we have $230.40. Okay. So then what we're going to do is just figure out what x is. So I'm going to divide. So 230.4 divided by 360 is 0.64. So x squared equals 0.64. Then we're going to square root both sides. So x is going to be 0.8. So here's the thing. What 0.8 represents is the amount that she had remaining each time. But it's talking about how much she spent. Well, zero point 0.8 is 80%. So if she kept 80% of her money each time, that meant she spent 20% to buy the dress and then to buy a wig. All right. So I didn't want to put N in the problem. I wanted to just figure it out later. So what we have to be able to do is understand that when you take 20% off of something, you should multiply it by zero point 0.8. Or in a problem where you figure out that you are multiplying by zero point 0.8, understanding that that really represents 20%, a 20% decrease, either a discount or in this case, the amount that she's spending. All right, moving on to our next problem. So we have a right triangle ABC and right triangle DBC share the same hypotenuse. So let's say we have something like this. So BC should be the hypotenuse. So this is A. So right triangle ABC. Um, this is weird. It might not look great because this is not necessarily like a rectangle. And we'll call that DBC, which has a length of the same hypotenuse, which has a length of K units. The measure of angle ABC is 45 degrees, and the measure of DBC is 30 degrees. Okay, that just tells us that this is a 45, 45, 90, and this is a 30, 60, 90. So I'll just put those in. Again, even if it doesn't look right, that's fine. The math will work out fine. The perimeter is this random thing. What's the value of n? All right. Well, if we want the perimeter, let's find all the sides. So we do it like this. We have to know that a 45, 45, 90, the ratios are x, x, and x root 2. All right. So that means k is x root 2. But we want the x. So that's k divided by root 2 is x. So each of these are k divided by root 2. But that I should rationalize. I feel like that's going to help me later. So that is k root 2 over 2. All right. So each of these are k root 2 over 2. Now, if I know a 30, 60, 90, the hypotenuse is double the short leg. The short leg is the one opposite 30. So the way that works, it's x, x root 3, and 2x. Well, this one's a little easier. If this is k, then the short side is half of that, so that's k over 2. And then the long leg is that times root 3, so that's k root 3 over 2. Okay, so now the perimeter. We are going to add all these together. Well, k root 2 over 2 um, plus k root 2 over 2 is 2k root 2 over 2. I'm going to leave it as that for now. I understand the 2's cancel. You'll see why in a second. Plus k root 3 over 2 plus k over 2. The reason was because I want to be able to factor out a k over 2. So I'm going to do that because I left this k over 2 in here. So I take out a k over 2, and then I have 2 root 2 left. I have root k root 3 left, and then I have a 1. So let's match this up with what we have here. Um, oh, my bad. We don't have a k. What am I doing? This k is gone. I took the k out. We just have a root 3. So this kind of works out perfectly, right? We have a k over 2. We have a root 3. We have a 1. And then we have this root m. So the only thing left over that could represent root m is this. So we just have to find the value of m. Well, one way we could do it is just set them equal to each other. I hope you recognize 2 root 2. You've probably done it a lot over the years. But if you don't, we'll square both sides. So m is, if I square this, squaring 2 gives me 4. Squaring root 2 gives me 2, and that equals 8. So the answer to the problem is 8. Again, if you simplify the square root of 8, that is 2 root 2. A lot of us, I'm sure, recognize that. You've probably had to simplify square root of 8 in various math classes a lot. So 2 root 2 is the square root of 8. But if you don't get it, just set them equal to each other. This is a super challenging problem, by the way. But we have to know our 30, 60, 90s, our 45, 45, 90s. And then we're trying to just match it up with what this looks like, which is, again, how I knew to factor out the k over 2. I wouldn't normally have done that. But you got to like kind of look at either use the answer choices or stuff in the problem to kind of guide you onto how you make your decisions. All right, let's keep it going. So number 3, A equals B and C equals D, and the equations have no solution. What must be true? Yeah, this one is interesting. I think what we have to be able to do is realize that for it to have no solutions, um, the slopes have to equal each other. All right, so no solutions would be parallel lines, and parallel lines have the same slope. So that's where I would start here. And realizing, so for this one, to find the slope, I want to get y by itself. So by is negative ax plus 3, divide by b. And the only thing I really care about from this is the negative a over b. That's the slope. And then for this one, if I do something similar, I have dy equals negative cx plus 9 over 2, and then I divide by d, right? I don't really care about, 9 over 2 over d. Again, I care about the slope, which is the coefficient of x. That should equal this. So this I know is true. The slope of one has to equal the slope of the other. The fact that A equals B and C equals D, um, I don't know really. I think they just told us that to kind of confuse us because this has to be true. So it says what must be true. And if this is true, we could flip each one. You're allowed to flip each side, which would lead to C, right? Negative B over A equals negative D over C. Because if you take the reciprocal of each side, that is mathematically equivalent. Um, it is possible for A to equal C, but it doesn't have to. So the key word is must, right? If A were to equal C and B were to equal D, then we would get a no solution situation, but that doesn't have to be true. What absolutely must be true is the slopes have to equal each other. Okay. And our last challenge problem, what we have is line A is perpendicular to line B. The y-intercept of line A is that, and the line, okay. What is the equivalent slope of line A minus slope of line B? All right, so what I'll do here first is the equation for line A, all right, is y equals mx plus c. They told me that c was the y-intercept. Then if I find the equation of line B, that's y equals, all right, well, we know it's perpendicular, so it's the negative reciprocal of this. That's negative 1 over m. That's the reciprocal of m, or the opposite reciprocal of m. And then they told me the y-intercept was d. What is the equivalent slope of line A minus line B? All right, still doesn't really tell me a lot, but what I do know is that there are no y's in my answer. So I want to get rid of y. So I'm going to get rid of y by substituting. So I'm going to say mx plus c equals negative 1 over mx plus d. Okay, still a little strange, but I got a lot of like C minus D's and D minus C's in my answers. So let's get the C's and D's on one side. So MX, I'm going to add this 1 over MX to this side, and I'm going to subtract C to this side. So I'm going to get D minus C. Okay. I also see X's in my answer. So I'm going to divide everything by X, right, to get X on the other side. So what I end up with is M plus 1 over M equals D minus C over X. All right, well, that looks pretty good because they want the slope of line A minus the slope of line B. Well, the slope of line A minus the slope of line B is M plus 1 over M because minus a negative turns to a plus. So the D minus C over X, that's our answer. So again, the problem didn't make a lot of sense from the beginning, but it's about getting started and just doing stuff. You don't want to just stare at a problem and think and think and think. Just get started, right? We know if the y-intercept is c, that gave me this equation. Then I can get this equation because it's perpendicular. Then I don't want y, so I substitute is how I get rid of things. And then you just keep going, and eventually you get to something that works out. Again, these problems were designed to work out, so if you just keep working through algebraically, looking at your answers to help you make decisions, you'll eventually get there. All right. Now let's start with our lesson or the problems related to our topic tonight of linear functions. Okay. So the table shows three values. We want the value of m plus b, and it's giving us, so basically it wants the equation of this. All right. Well, the way we would want to find the equation is first by finding the slope. Well, slope is change in y over change in x. Well, I know the x is going up by 6, and the y is going up by 132 minus 54. That is 78. So the slope is 78 over 6. So 78 divided by 6 is 13. So the slope is 13. So we have y equals 13x plus b. I know there's a minus b, but we'll get to that. Now I want to find b. Well, I can find b by substituting any point in. So I'm going to say 54 equals 13 times 7 plus b. 13 times 7 is 91. And then subtract that over. So 54 minus 91 is negative 37 equals b. So my equation is now y equals 13x minus 37. Okay. So that means that m is 13 and b, well, it's minus b. So b is just the 37. I realized the b we got here was negative 37, but they flipped it on us, right? They do these things to confuse you, right? And then they want us to add them together. So 13 plus 37 is 50. All right. So again, I got this b because it's normally plus b to be negative 37. But when I plug it into the equation, and this is the equation I get, and I match it up, right? If I just put it right under here, maybe it's easier to see that m is 13 and b is 37 because the minus is already, they already put the minus in there. All right, number two, we have a model with the boy's age is A and the weight is W. All right, we don't need to read the whole thing. What's the increase in the boy's weight from his third to his seventh birthday? Well, we could just plug in three and we could plug in seven and then just subtract them. But what's going to end up happening is the slope is nine. All right. That means so m is nine. All right. And let's remember slope is rise over run. So that means the boy's age is the or sorry, the boy's weight is the y. So that's nine doesn't say what. So oh yeah, in pounds. So that's 9 pounds per 1 year. So the boy is essentially gaining 9 pounds every year. Well, this is a 4 year span. So in 4 years, he's going to gain 9 times 4 pounds, which is 36. So that's the quickest way to do it. Just multiply the slope by four. If that's a little confusing for you, just plug in three. You'll figure out his weight after the third birthday. Plug in seven. You'll figure out his weight after seventh birthday and subtract them. And sure enough, you will get 36. All right, number three, the no solution type problem. Here's the deal. In order for there to be no solution, we could look at each of these as being lines if we were to like graph it in Desmos, and we would want those the solution to the equation would be where those lines intersect. But if there's no solution, those lines should be parallel, so they should have the same coefficient of x so that they have the same slope. Okay? Or if you're just used to solving these, you would be bringing one of the x's over to the other side. And if the x's cancel out and what's left is not equal to each other, that also creates no solution. So either way, this and this have to be exactly the same for us to have no solution. These are already different. The person making the problem has to deal with that. So k just has to be 3/5. That's all you have to do in that problem is realize that the coefficient of x has to be the same on both sides in a linear equation to get no solution or infinite solution. In infinite solution, the other value, the constant or the y-intercept, they would be the same. But again, we don't have to worry about that. If they make those the same, the person making the problem would have to change it to an infinite solution problem. All right, line K has this equation. What is the line J is perpendicular. All right, well, the slope of this line is 7. All right, that's the slope. We should know y equals mx plus b. The coefficient of x is the slope, and perpendicular is the opposite reciprocal. We already talked about that in one of our challenge problems. Well, this is 7 over 1, so the reciprocal is 1 over 7, and it's the negative or the opposite reciprocal, so the answer just has to be B. All right, so pretty straightforward, but I want to go over these to make sure that we know these concepts related to linear functions. All right, next concept is a slope problem. Which of the following must be true? These all talk about increasing and increasing, so that is talking about the 9 over 2. So the way I would do this is the slope is 9 over 2. Slope is rise over run. The rise is the p in this case. P is in the place of y. So 9 is P and 2 is K, right? Change in Y over change in X, change in P over change in K. So I just want to find the answer that talks about P going up by 9 and K going up by 2, and that's C. 1 in 40, I don't know where that came from. I guess they think that we're going to use that. 2 in 4.5. No, and 2 and 9 is close, but this is P by 2 and K by 9. All right, so slope, rise over run, they're going to change letters on you. So get more used to the position of things. Y equals mx plus b. This is the P is the Y and the K is the X. Okay, let's keep moving. Number 6. In the xy plane, line L passes through this point and has a slope of -1/2. What's the x-intercept? Okay, so two pretty quick ways to do this. One is really knowing, we've talked a lot about slope-intercept form, but I chose this problem because I wanted to make sure that we remembered about point-slope form. The reason that this is easy to use is because all I have to do is plug in the slope and a point. So I get y minus 2, right? Y1 is this one, it doesn't really matter. And then my slope is -1/2, and my x1 is 2 as well. Now, we're used to in school at like solving this to get it y equals mx plus b, but we don't need to because what they want is the x-intercept. Another reason I chose this problem is to go over the idea of x-intercept. If they want the x-intercept, you really have two options. You could just throw this into Desmos and find the x-intercept, just look at it. That might not be bad. Or x-intercept is making y 0. So just make y 0 and you get -2 equals -1/2 x minus 2 and solve for x, and that gives you the answer. So I'm going to multiply each side by 2 to get rid of this. So, sorry, -2. So that gives me 4 equals x minus 2, right? So I just want to I just said that real quick, but I should be multiplying this side by -2 and this side by -2 because -2 times -1/2 is +1. And then add 2 and I get 6. Now, another option is to just look at it. If you go, the slope is -1/2. That means you're going down 1 over 2. Okay. Well, if I go down 1 over 2, those coordinates are 4 comma 1, right? When I go down 1, that's the y, and over 2. And then if I go down 1 over 2 again, that's 6 comma 0, right? The y goes down 1 and the x goes over 2. Right, so many ways to attack this problem. This would be the quickest. So if you just did that, that's fine. We should know this way as well. And we also should know that Desmos works. But the Desmos is always, you're always thinking about how long would it take me to type something in and then look for the answer. And that depends on how quick you type and things like that. But sometimes just plugging in and solving, you can do that more quickly than plugging into typing into Desmos. So again, they're the things you have to think about when you're taking this test, to again give yourself the most amount of time to do all the problems. All right, number 7, we have just a function problem. So let's go over functions. F of g of 5. We work inside out with functions. We do g of 5 first. So g of 5 is just plugging in 5 to the g function. That's 2 times 5 minus 3, which is 10 minus 3, which is 7. So we're replacing g of 5 with 7. So now we're doing f of 7, which means f of 7 is going up to this function and replacing x with 7. So that's 3 times 7, 21 plus 7 is 28. Right, pretty straightforward, but again, just wanted to go over how you evaluate composite functions. So start inside and work out. All right, let's keep going. So we got another here at number 8. It's true for all values of x. That's a fancy way of them saying that there are infinite solutions, which we talked about earlier. Infinite solutions is when no solution, same idea. You need the x on each side to be the same, and the y-intercept or the constant on each side will also be the same. But they make that happen here. -7 is -7. So again, they worry about that. Just make sure the coefficient of x is the same on both sides. So 5a has to equal 1.25. So all we're doing is 1.25 divided by 5, and that's 0.25. Right? So if A were 0.25, 0.25 times 5 will be 1.25, and you'd have 1.25x on each side. And if you were to actually solve it, the x's would disappear, and you'd get infinite solutions. Or if you were to graph each side, you would have the same slope, same y-intercept. The lines would be on top of each other, and you would still have an infinite number of solutions. You could also do this problem using Desmos. If you just plugged in each side, you would want them to be on top of each other, and you would just make a slider and try all these values. And when you plugged in 0.25, you would see that they were on top of each other. And every other value would give you a clear intersection, like one intersection. Okay, moving on to number 9. Let's see. I want to try to do this without reading much of the problem. So let's just go right to the question. At what value of t will the height of the cactus increase by 1 centimeter? Well, it starts out at 17 centimeters. So if we increase it by 1 centimeter, let me make sure I'm reading that right. What value of t will the height of the cactus increase by 1 centimeter? Well, yeah, it started at 17, so that means we just want it to be end up being 18. So I want to know which value of t. So I just do this. So clearly it had to increase by 1. So when I do 18 minus 17, I get 1. And then I multiply over 2.5 and I get 2.5 equals t, which makes sense. So if I plug in 2.5, 2.5 over 2.5 is 1, and it's going to increase by 1. It started at 17. All right. Another option here is to just check your answers. Just plug them all in and see which one increases it by 1 or takes you to 18. All right, number 10. We got a graph going on here. We want the x coordinate of point C. So we just want this point. And the lines are perpendicular. Okay, so it's similar to a problem before, just with different given information. So what we want, we know this is the origin and we know this point. So we want to find the slope. So we want to think about the rise over the run. So that's up 8 over 6. And 8 over 6 is 4 over 3. So the slope of this one is 4 over 3, which means the slope of this line is negative 3 over 4. So one way to do this is to use, again, point slope form. So y minus 8 equals negative 3/4 times x minus 6. Now, what you could do, again, like the other problem, is just throw this in the Desmos and look at the look at the x-intercept. Or if we want to do it by hand, just anytime you find an x-intercept, right, the x-coordinate of point C is the x-intercept. Replace y with 0. So if I replace y with 0, I get negative 8 equals negative 3/4 times x minus 6. Multiply each side by negative 4 over 3. That cancels that out. This gives me 32 over 3 equals x minus 6. And then I'm going to add 6 to both sides. 6 is really 18 over 3, so 32 over 3 plus 18 over 3 gives me x, which is 50 over 3. Now again, the other acceptable answer, 50 divided by 3, is 16. So you would do 16.667. 1, 2, 3, 4, 5, 6. That is wrong. Make sure you have 5 characters that the SAT will let you put in. So that's why I counted afterwards and realized that I counted wrong. That's correct because the decimal counts as a character. So you would do 16.67. They would also accept that. That's the answer you would likely get from Desmos. Or if you just did this whole thing by calculator, right? So I did a lot of this in my head, but don't do that if that's a problem for you. Just do negative 8 times negative 4/3 in the calculator, add 6, and then you could do you could change it to a decimal, either to a fraction in Desmos or on the TI-84. Again, a lot of different ways to do this problem. The concepts are what I'm more concerned about, and anybody that wants a good score, knowing that the best score possible is just making these decisions. And some of them are easy decisions, but some of them are different for every person. All right. So again, it might be easier for someone to just throw in 0 here and solve than to open up the window for Desmos, type it in and look. I know that's not that difficult. I'm not making it out to be that difficult, but it still takes time. So it's all a game of which one is going to take more time. All right, number 11. We're getting there. Okay. So here is an interesting problem. I like this one because they don't really go over this much in school. They're saying which of the following points lie on the graph of the equation in the xy plane for each real number r. It's kind of comes from like an infinite solution type problem, but they usually in school you just say there's infinite solutions. They don't make you give the coordinate pair. So it's a coordinate pair that represents every solution on a line. So there If you were giving this and it was open-ended, it obviously wouldn't be SAT because you wouldn't have R. But in a school problem, if they gave this to you, um, there would be two acceptable answers. One of those answers would be to make y equal to R. So do this. Make y equal to R and solve for x in terms of R and put that here. Or make x equal to R, solve for y in terms of that and put that here. So there would be legitimately, if you gave this to a group of people, there would be two acceptable answers. That makes me lean away from A because that doesn't have an R in either position. I'm not going to get rid of it yet. I guess it is possible to do that because they can like do it in weird ways on the SAT. So let's just leave that going and let's just choose one of these. So let's say I do the first one. I make Y R. So I get 2x plus 5r equals 9. And then what I'm going to do is just get x by itself. So 2x equals negative 5r plus 9. Divide by 2. Divide everything by 2. So negative 5 over 2r plus 9 over 2. And then I look at the answer that has an R in this position, and that's wrong. It's supposed to be negative 5 over 2. So then I go and I say, all right, maybe I'll put R in the other one. So I'll make XR. So 2R plus 5Y equals 9. Now I want to get Y by itself to figure out what would go here. So 5Y equals negative 2R plus 9. And then I'm going to divide everything by 5. So y is equal to negative 2/5 r plus 9/5, and that's what I have here in C. So A really didn't make sense, and D is just, again, they divided wrong. Okay, so I would have honestly if I were taking this test, I would have done this one first, simply because there's two of them. So that way, if it was wrong, I'd be able to eliminate two answers in one shot. The only reason I did the other one first was to just show you what it would look like to to choose the wrong one, essentially. I don't know if that makes any sense, but it did in my head. I just wanted to go through what a wrong, like doing it, what the wrong one would look like. But again, it's not a wrong answer. Um, like this is another legitimate answer. It's just not one of the ones that's here. Because obviously they can't have two correct answers on a problem. All right. Moving on to number 12. So we've got one where it's infinite solutions. So we've got to do a little bit of work first. So 23x minus 5ax minus 10x equals 4x. So then I could do, there's multiple ways to do this. I'm just going to keep going with this. So I'm going to say 23 minus 10 is 13x minus 5ax equals 4x. And then to avoid negatives, let's just do it this way. Negative 5ax equals, I'm going to bring this over to negative 9x. So what has to happen is, in order for there to be an infinite number of solutions, the coefficient of x has to be the same on both sides. So negative 5a has to equal negative 9. So a, if I divide the negatives out and then I divide by 5, I'm going to have 9 over 5, which is C. Okay, moving on. All right, so number 13, we've got another one where it says that which of the following must be true. So we need there to be no solution. Um, so what we do is which of the following must be true? Well, the first thing I'm going to do is I'm going to distribute this. So I'm going to 7x plus 3 equals ax plus ab. And then I'm going to analyze it. And I'm going to say, okay, the coefficients of x must be the same for there to be no solution. So a definitely must equal 7. There's no scenario where a equals something other than 7 that would lead to no solution. So that must be true. Okay. Um, Now B equal to 3. Okay, so now I'm going to rewrite this. So I know A equals 7, right? No doubt about that. So now I have this. All right. Well, if B equals 3, this is the only other thing that has to be true for there to be no solution is these have to be different. Okay. So these have to be the same and these have to be different because if they're the same as well, then it's an infinite solution problem. But I want no solution. So I think about it. Well, B could be 3. It definitely could, but it doesn't have to be 3. So 2 is wrong. Okay, so B could be 3. It could be 7x plus 21. But it could be 7x plus 28. It could be 7x plus anything other than 3. So B could be 3, but it doesn't. They're saying the word must, so it doesn't have to be 3. But this does have to be true because imagine B was 3/7. 3/7 times 7 is 3. Then we would have 3 and 3, which is infinite solutions. So it must not equal 3/7. So B can be anything except 3/7. It could be 3, but it doesn't have to be 3. So the answer ends up being D, Roman numeral 1, Roman numeral 1, and Roman numeral 3. Okay, now to number 14. So what's the value of A if B equals 2A? So the first thing I would do is think of this point. If we want A, this is A comma 2A. Hmm. So we have a couple different ways to do this problem. Let's think about the quickest way. I think what I'm going to do is I'm going to just find the equation of the line. I'm just running through real quick to see if there's like a shortcut. Yeah, I'm just going to find the equation of the line. I'm going to do it like this. Y equals the slope is down 3 over 5, so negative 3/5. X plus 3, the y-intercept is clearly 3. Yeah, I'm just going to, because I think you should be able to do that immediately. You should be able to get the equation of the line. The slope is just rise over run, so down 3 over 5. And then just plug in. Y is 2A and X is A. And then we just have to solve for A. Well, I like to solve these. I don't like to deal with fractions, so I'm going to multiply everything by 5. So I get 10A equals negative 3A plus 15. And then I add over and I get 13A equals 15. And now we can see that when I divide each side by 13, I'm going to get 15 over 13. All right, I will do that a lot too. I would like stop at the very last step if you're able to, and just circle, obviously not circle the answer, click the answer on the test, as opposed to just like doing this. Like I know we're like it's so ingrained in us from school to do that, but again, that's all that's doing is wasting time. Um, Unless it's something that you just really feel like you need to do, or else you get confused, which is totally fine too. But if you're able to, definitely little things like that, getting to the last step and then just circle, like putting the answer, can be super helpful. Okay. Moving on to number 15. Which of the following is parallel and goes through this point? All right. Notice every answer is in point slope form. So we're going to use point slope form. So that's y minus y1. Well, that's plus 3 is equal to some slope. I'm going to keep it as m. And then it's x minus negative 2, so plus 2. So right away, I have to have that. So that allows me to eliminate those two answers. So really all I'm doing is finding the slope. All right. And the slope is just taking this and putting in the slope intercept form. So 4y, I want to bring the 3x to the other side, negative 3x plus 12. And here's another one where you can just not do the very last step. We're going to divide everything by 4, which means the slope is going to be negative 3 over 4th. So it's just that. Right? I don't need, again, you could do this, but I don't care about the y-intercept. So all I know is the slope will be negative 3 over 4, which gives me answer choice D. All right, moving on to our last problem, number 16. They want the x-intercept. All right, this is similar to a problem that we did earlier. We want the equation of the line, and then we want the x-intercept. I'm actually going to do this differently than that one because now that I think about it, a couple of the problems I chose to do point slope form. I probably should have done that before. I don't believe that I did. So what I would do at first, no matter what, I have to find the slope. So slope is rise over run. So 149 minus 114 is 35, and 17 minus 12 is 5. So it's going up 35 every 5. So the slope is 35 over 5, which is really just 7. Okay. So rather than, I think what I did on the other problem, I did this. So rather than doing that and solving for b, let's look at the other way to do it. So use point slope form. So I'm going to choose the first point still. So y minus 114 equals slope of 7 times x minus 12, right? I chose 12, 114. And then what I can do is, since I want to find the x-intercept, I don't actually want the equation of slope-intercept form. X-intercepts are replacing y with 0. So then again, we've talked about how you could just throw that in Desmos and find the y-intercept, or I could just solve it really quickly. So again, I'm just doing negative 114 divided by 7 is, okay, so you get a decimal. So here's what I would do. Leave it as negative 114 over 7. All right, that gets rid of this. And then I'm going to add 12, and then just put that in the calculator. And then if you do math enter enter, it'll give you negative 30 over 7. Yeah. I just want to double check that that's right. Whoops. Yeah. So you just get negative 30 over 7. And that's it. Or if you don't plug this into Desmos, if you use Desmos like the calculator part of Desmos, that has an option too. You just click that button and it'll change it to a decimal. But you don't want to take this decimal and round it and then add 12 because then it won't give you this. Because then what you're stuck with, if you get the decimal answer, you're just stuck with now checking which one of these equals that, which again might not be too difficult, but it just starts to waste time. Okay. All right. That's it. That's the end. So I hope that was helpful for everybody. Thank you for attending or thank you for watching this on YouTube. Check out our TikTok, check out the YouTube. We also offer one-on-one tutoring. If you're ever looking for more than just the free content that we put out, call or text or email us. All right. Hope that was helpful.